All right, students, welcome to the prerequisite exam review. Um, Not that this is funny, but it seems like every time I'm about to do a review, it always comes down to getting sick or I got a really stuffy nose. So my apologies for my voice not being the best in this particular video. So this will be for both classes, the online and the face-to-face. This is the same review for both classes. Okay, so let's try to knock, knock two birds with one stone. We're gonna try to do this over maybe 2 or 3 videos. If we try to do this over one video, it will be too long and it will get extremely boring, and we don't want to do that. So let's begin. It seems like the first question wants us to add some fractions. If we need to add some fractions or subtract fractions, we need a common denominator, okay? In this particular case, it seems like that the common denominator is 9. And the reason I say that is this is already a 9, but we can make this denominator a 9 by multiplying by 3. But if we do that here, we must also do the same thing in the numerator. So now that we have a common denominator, we can perform our addition, which in this case will be 3 times -2, okay? 3 times -2, which is -6, plus 4, okay? Here we get -2 over 9, and we cannot simplify this fraction. On the second example, it seems like they want us to multiply some fractions. Okay, so let me rewrite this. Maybe I can make it a little bit better for you. -6 over 1 times, and then we have -7 over 3. When we multiply across. Okay, so in this case, first of all, let me get the sign correct. So negative times a negative will be a positive number. And so therefore we have 6 times 7, which is equal to 42. 1 times 3 is equal to 3. And we can simplify this. We can do a little bit better here. 42 divided by 3, that will be equal to 14. Question number 3. Here they want us to divide, and they got some fractions, and then, this could also be ran as a fraction. So let me say it like this. We have -5 over 3 divided by -9 over 1. Okay, so let's get the sign right. A negative divided by a negative will be positive. Okay, we got the sign right. And in this case, we could do cross multiplication. So 5 times 1 will be 5. And then in the denominator, we get 9 times 3. 9 times 3, which is 27. And this fraction doesn't reduce. It is as good as it's going to get. Moving on to number 4. They want us to use the distributive property to remove the parentheses. What they want us to do is they want us to take this -5 outside of the parentheses and distribute it to every term that is inside of the parentheses. And I'm noticing they are 1, 2, 3. So I'm expecting 1, 2, 3 terms as the result. So negative times a negative will become positive. 5 times 2 is 10. And we have a u square. A negative times a positive will be negative, or in this case, minus. 5 times 6 will be equal to 30. Negative times a negative, the outcome is a positive. 5 times 2 is 10, and that has a y cube. Number 5, they want us to multiply these terms together here. Okay, so we are going to multiply numbers with numbers, same variables with the same variables. Let me say that a little bit nicer. Same letters with the same letters. Okay, And so let's begin. 2 times 7 is 14. 14 times 2 is 28. Okay. And now we do letters with letters. Here is a u square. So here's a u square times, here's another u cube. We keep the same letter. So in this case, the letter u, and we add the exponents. So we had 2, and then we put it together with 3. We get a total of 5. So u to the 5th power. The y's, we have a y to the 8th times a y. So in this case, we keep the same letter, y, and this y has an exponent of 1. So a plus 1 is equal to 9. So we get y to the 9th power. Okay, so we multiply the numbers and then letters with the same letters. In this particular example, number 6, they want us to use the power to power rule. This will be the power to power rule, which means that if we have a base raised to the n power, and then we raise it to another power, then we keep the same base and we multiply the exponents. Okay, so in this particular case, we have, I guess we could say -2 is one base. We have u, that's another base, and v, which is another base. So we have 3 bases. So basically, we could say this: -2 raised to the 5th power, u cubed raised to the 5th power, and v squared raised to the 2nd power. Okay, so let's get this sign correctly. That will be negative times a negative times a negative times a negative times a negative. So we get positive out of these two, positive out of those two. We get positive out of those two, but here we have a negative, and positive times a negative will be a negative. Okay, and now we have 2 to the 5th power. 2 times 2 times 2 times 2 times 2. That will be equal to 4. That will be equal to 4. This will be equal to 16. 16 times 2 is equal to 32. Okay, so let's go ahead and use now the power to power rule. We keep the same base and we multiply the exponents. So that becomes 15. 5 times 3. We keep the same base. In this case is the letter V. 5 times 2, which is equal to 10. All right, let's continue with question 7. I want us to simplify. So we have a multiplication here. And the way I know this is we got some parentheses going on here. Okay. Notice that there's nothing in between those parentheses. So this is an indication that it must be a multiplication. Again, we multiply numbers with numbers, the same letters with the same letters. Okay. But before we do that, I'm noticing that this parentheses here is raised to the 2nd power. So I don't know if you remember this, but when I learned this, they used to say something like PEMDAS. They probably say something different now, but I remember this. And it said that you have to do whatever is inside of the parentheses first. But in this case, there is no other operation going on here nor here. And then we have an exponent. We see that here. So before we take care of this multiplication, that's what the M stands for, before we take care of this multiplication, we must apply the exponent 2 on this 2nd parentheses. So let's see what that looks like. So this is the first parentheses, nothing is happening there. But on the second parentheses, we're going to have to apply this power of 2. Remember, similar to the previous example, these are all bases. The -2, the x, the y, and the z, okay? And each one of those is going to be, we're going to apply the power to power rule, okay? So in this case, we could say that will be -2 square, okay, -2 square. Then we have x to the 4th power square. Then we have y square. And then we have z cubed square. Okay, so we're not doing anything to the first parenthesis, so I'm just going to rewrite it. And now let's see what happens. So a -2 times a -2, a -2 times a -2, that will be positive 4x. We keep the base and we multiply the exponents, so we get an exponent on 8. We y square because the exponent here is 1, and z raised to the 6th power. We're multiplying. But now we're not raising to a power, we are multiplying. So this is a -1 times a 4, that becomes a -4. This x times that x, we keep the base. Since we are multiplying, we add the exponents. This is an exponent of 1. We are multiplying y times y squared times another y squared. We keep the y and we add the exponents. Why is this? Because we are multiplying. How come we're not multiplying the exponents? Because we are not raising a power to a power. Okay, hopefully you understand that. Z cubed times a z raised to the 6th power, that is z raised to the 9th power. And this is our final answer. For the next example, let's see what we got. We got a division. So, okay, we are going to divide, but it is opposite of multiplication. So we're going to keep the letters, the bases, but instead of adding, we are going to subtract the exponents. Okay, so let's see what this will look like. Okay, so fraction line here. Let's see if we can simplify this. We can divide top and bottom by 4. No, not 4. We could say 3. That's what I meant to say, 3. So this becomes, I guess we could have done 6 from the very get-go. It's so therefore 5 and 2. So we have a 5 and a 2. All right, so if you think about this, okay, we're going to keep the same letter, okay, the letter W. But notice that there are more here. There are 5 of them, okay? There's 5 of them, okay? 5 of them in the denominator. But notice that we have 4 in the numerator. So what happens is we cancel 1 for 1. Notice that we had 4 here, we had 5. If we were to cancel 4, there will be 1 left over in the denominator, okay? And when you think about the x's, okay, notice that there's 3 of them up here, 3 of them in the denominator. They will just completely cancel each other out, and there will be no x's left in this particular example. So the final answer for this example is just 5 over 2w. Okay? All right, so let's see what's going on with 9, because I'm noticing some negative exponents. And they want to write the answer using only positive exponents. And the way I like to explain negative exponents is by saying that they are not what they need to be. They're not in the right floor. Either you are in the numerator and you're supposed to be in the denominator, or you are in the denominator and you're supposed to be in the numerator. And I think that's what, the easiest way to try to explain negative exponents. You're not in the right floor. So let's take care of that first. I'm going to keep that 12 for now. I'm going to keep this 2. I'm just really concerned with just putting the um, the the letters with the exponents in the right spot. So this m to the 8th has a positive exponent. So it is where it needs to be. Okay, so I'm going to take care of the numerator first. This n to the negative 7th power. Oh, wait a minute. Hey, buddy, you're not in the right floor. You're supposed to be down here with a positive exponent. The same thing with this p to the negative 5. Well, hey, buddy, you're not in the right floor. You're supposed to be in the denominator with a positive exponent. All right. There's something about mathematics that we just do not enjoy negative exponents. We enjoy positive exponents. So let's see what's going on here. We got an m to the negative 4. Hey, buddy, you're also not in the right floor. You're down here. You're supposed to be up here with a positive exponent. And what about this n to the 6? Well, this n to the 6 is where it needs to be because it has a positive exponent. All right, now we can go ahead and take care of the rest of the little details. So let's see, 12 divided by 2, that's 6. That wasn't that bad. We're noticing there's an m to the 8th, an m to the 4th. We keep the same m and we add the exponents, okay? Down here, well, think about that. That's already gone, so let's not get confused there. But the n's, there's 7 of them and another 6. That makes 13 n's and p to the 5th, where it has nothing else to combine with. There's not another p, so therefore it is just p to the 5th power. And there it is. There's the answer. All right, moving on. Oh, so we got some more negative exponent stuff. All right, good stuff. I like it. Again, it seems like we need to apply the power rule first. Let's apply the power rule and then we'll decide what happens with the exponents. So this 3 gets an exponent of negative 2. This a gets an exponent of negative 2. Well, I guess what I should do before I do that is simplify what's inside of the parentheses first and then take care of the exponent. Okay. I want to follow PEMDAS. So I want to simplify what's inside of the parentheses first, and then I'll take care of the exponent. So we have 3. Let's see. There's 1a here, but then there's 3 of them here. If we completely get rid of 1, that will leave us with 2a. So we have a squared. B's. Well, there's 1b here, and there's 4 of them there. So if we completely get rid of 1, there will be b cubed. Ooh, that looks more like a question mark. There will be 3 of them in the numerator. And now we can go ahead and apply our negative exponent. So we apply the power to power rule, 3 to the negative 2, b to the negative 6. Remember that power rule. We multiply the exponents. A to the negative 4. Oh, I see some negative exponents. That means that these people are not where they're supposed to be. They're not in the right floor. This 3 to the negative 2 is supposed to be down here. This b to the negative 6 is supposed to be down here. And this a to the negative 4 is supposed to be up here. And to make this a little bit nicer, 3 squared is equal to 9. There it is. Again, something about mathematics and writing the answers with positive exponents. Okay, it seems like we're kind of leaving that alone for now and moving into something with talks about degrees and leading coefficient and some good stuff there. Let's see what else is on the menu. Seems like we're about to add. Okay, so we got some more of the same thing for quite a few. This page is about maybe some what is that? Radicals. Okay, we got some. Okay, so then we got some factoring. Okay, let's keep rock and rolling. Okay, so if we were to write this polynomial because it has 1, 2, 3, because it has more than more than two terms. So we could call this a polynomial. Okay. So if we were to rewrite it with the highest power first, and then the term after that with the smallest power, until writing it in order per se, we have negative u to the fifth power minus 5u cubed plus 15. Since the 15 has no u, it will be the very, very last term. The first term, the one with the highest power, is called the leading term. The leading term. And so in this case, is this one here. The leading term has the leading coefficient. And it also has the degree of the polynomial. So the degree is the highest power, which in this case is just the number 5. What is the leading coefficient? In this particular example, the leading coefficient is the number -1. Okay, it could have been 4, it could have been 5, it could have been -2/3, but in this particular example, it is the number, it is the coefficient of the leading term, and in this case happens to be -1. Okay. 12. It wants us to simplify. Okay, so what I'm noticing here is that is the difference, a subtraction between two polynomials here. And so therefore, nothing is going on here. There is no distribution to apply. So we just have u squared plus 3. But here, there is a distribution of this minus or this negative sign, okay? And that's going to play a critical role here because this positive value will become negative. So now we have -7u squares or minus 7u squares. This negative and this negative become positive. So now we have 6u's. And then this negative and this positive will make this -5. Do we have any like terms? Well, I'm noticing that there is a u square here. There are now -7u squares. So if we combine terms, we get -6u squares. There is now a 6u. This didn't combine with anything. But I'm noticing that this 3 can be combined with this -5 to make -2. Okay. So just for fun, I guess, in this case, what will be the degree of this polynomial? The degree will be 2. What is the leading coefficient? The leading coefficient in this case will be -6. Just to reinforce what we did in the previous example. Easy questions. We should all be able to get these questions right. on their review, and of course on the exam if they show up on the exam. All right, let's finish this out. Let's see. We have some distribution again. It seems like we're really practicing this particular skill. We are distributing the negative 2u squared over this parentheses. So let's see. Really wants us to, test that negative times a negative skill. That becomes positive 10. We are multiplying, so we keep the same u and we add the exponents. Negative, negative, that becomes positive 12 u. There is a u squared and just a u. We are multiplying, so we keep the same u and we add the exponents. So we get q cubed. All right, we go ahead and pause for a second. All right, up right where we left. Let's see, I think this is kind of on the way, but how do I get rid of that? Okay, let's do this. We need to multiply. So, a few ways to do is we can think of FOIL here. If you're familiar with FOIL, we're going to multiply the first terms. Oh, wait, I'm doing this wrong. I think they're referred to as the first terms, the outer terms, the inner terms, and then the last terms. That's what FOIL is all about, okay? Or we can think about this as being double distribution. So let me see if I could do that as well. So what we're saying is that we're going to distribute these two terms over these two terms over here. So what that will look like is using that definition, double distribution, it will look like this: 3 times 3 minus 7y plus 5y being distributed over 3 minus 7y. Okay, or if you prefer FOIL, go ahead and do FOIL. Nobody's saying you cannot, but maybe I could try to, try something a little bit different. Okay, all right. Here we have 9 minus 27y. Here we have 15y minus 35y squared. Why squared? Because y times y becomes y squared. Okay, so let me rewrite this in proper form. Since I'm noticing this is the leading term, it's got the highest exponent. I'm going to write that first, negative 35 y squared. Here, I'm noticing that we can combine these two terms together, okay? So here we have a negative 27y plus 15y. That becomes negative 12y's. And then the lonely plus 9 at the very end. What is the degree? Not that this question is asking for this, but nothing wrong with reinforcing that skill. The degree is 2, and the leading coefficient is negative 35. All right, let's see what we got. Let's try to do all the way up to 17. We'll stop this video, and then we'll do another video. Let's call it part 2. Otherwise, this will become too long and boring. All right. Okay, rewrite without the use of parentheses. What this means is we're going to multiply 3 minus 2u with itself 2 times. Okay? And for this one, I guess I could use FOIL. The first term, so we get 9. The outer terms, we get negative 6u. The inner terms, we get negative 6u. And then the outer terms, we get positive 4u squared. Why positive? Negative times a negative becomes positive. Writing this in order, we get 4 u squared. Combine these two like terms, we get negative 12u. We're just combining, so they're in total negative 12u's plus 9. All right, I think that's enough of that. And now we're trying to do something different now with radicals. And they want us to simplify the square root of 63. Okay, let's see. The square root of 63 is the same as the square root of 9 times 7. Okay, this could be the square root of 9 times the square root of 7. And the square root of 9 is 3 times the square root of 7. So the simplification is that. Okay. Now you're probably wondering, where did I get the 9 and 7 from? Okay, so let me try to explain that a little bit further. We'll try to use a different color here. Let's see, maybe this color. 63. What I did to get the 9 and the 7 is, or why did I choose the 9 and the 7? I think that's best. Why did I choose the 9 and the 7? Well, I am going to write all the numbers that multiply to 63, beginning with 1 and 63, okay? Not 2, but 3 and 21, not 4, not 5, not 6, but 7 and 9 is the last pair of numbers that multiply to 63. Now, if we look at these 1, 2, 3, 4, 5, 6, if we look at those 6 numbers, which one of those is the biggest number we can actually take the square root of? And if you guessed it right, that is 9. This is the biggest number that we can take the square root of, that we can take the square root of. Therefore, that's what I use this pair of numbers as my, these are called factors, as the factors of 63. Why did that? Why did I do that? Because I could then take the square root of 9, which happens to be 3. Why is that? Why is the square root of 9 3? If you're wondering. The reason for that is because 3 times 3 equals 9. Okay, I'm going to leave that alone and move on to the next example. You know what? We'll take care of all of these radicals in this video. All right, and then we'll begin number 20 on the next video. Okay, so let's take care of all these radical business here. Go back to the same color ink that I had before. All right, so they want us to simplify this. So they want us to combine like terms. We can't really do that if we don't have like radicals. So check this out. Look at this. I'm going to say the square root of 45, and I'm going to break up 45 because I want to be able to take a square root of one of its factors. So what are all the factors of 45? 1 and 45, not 2, but 3 and 15. Okay, not 4, but 5 and 9. And then we got 6, 7, 8, 9. No, that's it. Okay, this is the list of factors. Out of this list of factors, which one is the biggest one we can actually take the square root of? If you said 9, you are right. So therefore, the square root of 45 is the same as the square root of 9 times the square root of 5. And we chose this because we can actually take the square root of 9, which is 3. So far, what we have is negative 3 times the square root of 5. minus 2 times, let's see if we can break up the square root of 80. The square root of 80, let's see. Wow, well, 1 and 80, 2 and 40, not 3, but 4 and 20, 5 and 16, not 6, 7, 8, and 10, 9. No, I think we're not going in the right direction there anymore. But out of these numbers, out of all these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this one has 10 factors. Out of those 10 factors, which one is the biggest one we can actually take the square root of? Well, we wouldn't be in this conversation if we could have taken the square root of 80. We would have done it from the very first time. And 40, let's see, 40. I don't think so. 6 times 6, or let me say it like this, 6 square is 36, and 7 square is 49. Not going to work out. 20, not going to work out. But 16, can we take the square root of 16? Blue, 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 blue. You are right. We can. And let's see what that is. The square root of 16 times the square root of 5. The square root of 16 is 4. Is 4. So we have 4 square root of 5. Okay. So we have negative 3 square root of 5. This becomes a negative 8 square root of 5. In total, how many square root of 5s are there? You got it. Negative 11 square root of 5. And there is that answer. Wow, that was crazy, wasn't it? Okay. Let's look at the next example. They want us to simplify. Okay, let's see. I think I'd take the long way there because I want to emphasize a particular skill. Okay. This is 6 times 8, which is equal to the square root of 48. We cannot take the square root of 48 from the very get-go. But can we do something better? Let's see. Let's list all the factors of 48. 1 times 48, 2 and 24, 3 and 16, 4 and 12, not 5, 6, and 8, and that's about it. It has 10 factors. Out of these 10 factors, which one we can actually take the square root of? The biggest one. We wouldn't be in this conversation if we could take the square root of 48. 24, so close. 5 squared is 25, so close. 16 again, 16 again. That must be it. This must be the right combination that we should use for this example. The square root of 16 times the square root of 3, because the square root of 16 is 4, times the square root of 3. That looks like a funky 3. There we go. That's better. All right. And then the last example for this video, because this is already like an hour long. All right. And it's getting boring. Okay. So we have the square root of 10 times 5 times a cubed times a to the 4th power. That makes it a to the 7th because we are multiplying. All right, let me write this a little bit better. That is the square root of 50 times a to the 7th power. Okay, maybe we could do something better than this, okay? I'm going to say the square root of 50. And here I'm going to say the square root of a to the 7th, okay? I'm going to just leave it like that. I'm going to simplify this and see what kind of jelly jam we can get out of this, okay? Well, to try to do this quickly, this will be 2 times 25. So that means we have The square root of 5 comes out of this. Let me rewrite it. Let me rewrite it so that I don't confuse you. Let me rewrite it so that I don't confuse you. That will be 25 times 2. The square root of 25 is 5. So we have 5 square root of 2. Here, what does it actually mean to take the square root of something? In exponents, that means that is 7 divided by 2. So this square root becomes a a fraction exponent, okay? So what it means is we're taking this 7 and we're going to divide it by 2. Well, what is that? That is a 3 and 1/2, right? 7 divided by 2 is 3.5, and 3.5 is the same thing as 3/2. But why did I do that? Why did I do that? Okay, because that is a cubed times the square root of a. That's what this means. Okay, that is a cubed times the square root of a. Okay, so notice that now we have 5a cubed, the square root of 2a. Wow, that last one was not the nicest, but it is what it is. It's just kind of working with radicals. All right, we're gonna put stop, come back to part 2 to see the rest of this review. All right, so let's go ahead and stop it, and I'll see you guys later.